Imagine a time when the sun didn't exist, only a vast cloud of cosmic dust floating through the emptiness of space. About 4.5 billion years ago, that cloud collapsed under its own gravity, triggering the birth of our solar system. But how did the sun ignite? Why do the planets move in perfect harmony? And what destiny lies ahead for our cosmic neighborhood? Join us on this incredible 3D journey as we uncover the awe-inspiring life cycle of the solar system, from its mysterious origins to its distant future. Stay tuned, because the universe's most fascinating secrets are waiting to be revealed.
Our solar system formed around 4.5 billion years ago. It developed from a cloud of very fine dust. The dust particles in this cloud stuck together to form clumps, like the dust bunnies under our bed. The dust clumps gradually grew until they formed a disc-shaped cloud. At the center of the cloud, matter became denser and the temperature increased. Thus, the forerunner of our sun was formed. Once the dust clumps reached a diameter of about 100 meters, they collided more and more frequently. Due to frequent collisions, their size increased, resulting in the formation of the planets. Since the kinetic energy was converted into heat energy during the impacts, the colliding units melted. As a result, heavy metals accumulated in the core of the planets, while low-density silicates became part of the mantle. Due to gradual cooling, the crust solidified, while the core remained fluid. This is how the inner planets were formed. The outer planets, however, were formed differently due to extremely cold temperatures. Ice particles stuck together, attracting hydrogen, helium, and other gases. After they were born, the planets of the solar system underwent numerous impacts, which changed their rotational velocity and the inclination of their axis of rotation. It was during such a collision, around 4 billion years ago, that the material from which the Moon was later formed broke away from the Earth. About 5 billion years from now, the Sun will enter the next phase of stellar evolution. Once the nuclear fusion of hydrogen stops in its core, the core will shrink, while the outer layers will inflate, and the Sun will become a red giant. About 7.9 billion years from now, the Sun will reach its maximum size during its red giant phase. It will be 256 times its current size. After engulfing Mercury and Venus, the Sun will probably engulf the Earth as well. Then the outer layers of the Sun will gradually separate from its core, forming a planetary nebula. The core itself will shrink even more, and it will become a white dwarf. In this phase, the Sun radiates its remaining heat into space. In the last phase of its life, once its remaining heat is depleted, the Sun will become a dark and cold black dwarf.
Isn't it amazing? Every atom in our world, even you, was born in the heart of an ancient star. The story of the solar system isn't just cosmic, it's our story too. If you found this 3D journey captivating, support our mission to make learning accessible and fun for everyone. Your likes, comments, and shares help us reach curious minds around the world. Subscribe to 3D Learning Lab and hit the bell icon to never miss our next awe-inspiring video. Explore more? Check out our community tab and join quizzes to test your knowledge of space science and beyond. Because learning never stops. Together, let's explore the universe, one discovery at a time. Thank you for being part of this incredible journey.